Alrighty, for this problem, we're trying to graph y equals 2 times x plus 3 times x plus 1. So this is factored form. Here's one factor, here's another factor, and well, really 2 is a factor as well. And when we're graphing in factored form, the first thing we need to do is establish what our roots are. And to find the roots, we're going to set each one of these factors equal to 0. And whatever will make this factor equal 0 will be my root. So when x is negative 3, this whole factor will equal 0. So 1, 2, 3 here is my first root at negative 3, 0. And my second root will be at positive 1, since 1 minus 1 is 0. And then the next part is to find the vertex. I'm going to need to find what my midpoint is between these two roots. Since the axis of symmetry is always smack dab in the middle, I can either kind of eyeball this thing. It looks like right at negative 1 is my axis of symmetry. So I can even write this as x equals negative 1. Or I could algebraically figure that out too. If my roots are negative 3, 0 and 1, 0, I could take the average between these two numbers. So the x will be given as negative 3 plus 1, and take the average of those two numbers, so I need to divide by 2. That's going to equal negative 2 over 2, which also gets me negative 1. So once I have this negative 1, I know that my vertex is somewhere on this line. All I know so far is that my vertex has a negative 1 as the x-coordinate. To find the y-coordinate, let's plug in negative 1 for x. So let's do that over here. Y equals 2 times negative 1 plus 3 times negative 1 minus 1. So I get y equals 2 times, that looks like it's going to be a 2, and this looks like it's going to be a negative 2. And 2 times negative 2 is going to give me negative 8. So my vertex is at negative 1, negative 8. And let's put that on the graph as well. 1, 2, 3, 4, 5, 6, 7, 8, and let's go green. Great. All right, and I'm really fine with that being the 3 points that I get for this graph. We're not going to have to make a table. We could make a table to find the points in between, but we've got our roots and we've got our vertex, so I'm satisfied with that shape there. To find the y-intercept, I have to remember that x equals 0 wherever my y-intercept is. All of these coordinates have an x equals 0 counter or a point to this. So if we plug in 0 for x, that's going to help me find my y-intercept. So y is going to equal 2 times 0 plus 3 times 0 minus 1. So this is going to be 2 times 3 times negative 1, which is going to equal negative 6. So my y-intercept is 0, negative 6. My domain is all real numbers, all possible x values in this thing. And my range is everything from this point upwards. So that's going to be given as y is greater than or equal to negative 8. And as far as the increasing, decreasing, this is a tricky one for a lot of us. But remember, every quadratic both has a period of increasing and a period of decreasing. So if I were to think about splitting this thing in half, everything to the right of my vertex is increasing. I'm going up as I continue from left to right to the right of my vertex. So this is when my quadratic, my parabola, is increasing. And a way to describe everything to the, let's get another color in here. A way to describe everything to the left, or rather to the right of the vertex, is by using this inequality. X is greater than negative 1. Everything to the left of my vertex is when I'm decreasing. So my parabola is going downwards when I am less than negative 1. And that's the increase decreasing. Concavity, this is opening upwards, so I'm concave up. And there you have it. We have ourselves a graph with a whole bunch of stuff written all over it and all of these properties.